Thank you, everyone. And for those of you who have seen me talk before, I usually have my title slide with some picture of jellyfish because I have a weird jellyfish fetish. But today I have a different picture. Does anyone know what this is? Any guesses?
I'm sorry to destroy your flow. Did you? I was distracted. Did you say you have a weird jellyfish fetish?
You said it.
Okay, just checking it wasn't my hearing. I'm sorry.
Yes. So does anyone know what this is?
A jellyfish.
No. It is. It's an underwater glacier. So therefore it's ocean things too. But yes, it's a glacier underwater. I'm not going to talk more about glaciers, but I just thought it was a cool picture. But I'm going to talk a lot about data. And data is this thing that's sort of below us all the time, this massive thing. We know it's important. And we have a worrisome feeling about it, and that worrisome feeling starts to get worse and worse. And in fact, this is an article from Economist in 2017, early 2017, where data was declared to be the world's most valuable resource, where it talks about Uber and Amazon, Google, and others being able to get value from this new oil, if you will. And the journal talked about this a lot. And you might ask, why? Why is data so valuable? And the root of it comes down to a realization. This realization came at least in early 2001. This is from a paper from Microsoft researchers in 2001. And what it shows basically is that the x-axis is the number of data points, the y-axis is the accuracy. And basically, and it's a log scale on the x-axis. So you'll see as you go from 200,000 to 1 million to up to 1 billion data points, the accuracy keeps going up and up and up. And you might think, okay, of course, yeah, that's obvious. But in the world of AI, up until this research, and even for years afterwards, this was not how AI researchers did AI to build their models. They would assume a fixed size data set, try to build that data set, usually fail, and then the AI wouldn't get shipped. This was my very first experience doing AI research in the late 90s. But what these researchers realized was data is unreasonably effective. And in fact, Google published a paper a few years later talking about that. Google themselves went on such a mission to gather more data that they would buy satellite companies just to get the data from those companies. So AI loves data. It has led to more accurate models, which for the likes of Google means selling more targeted ads, which means more money. And similar things for Facebook and the rest. So this is the connection between AI and data. AI extracts value from data in order to sell ads and more, for better and for worse. And the challenge, though, of course, is that we've seen a small number of companies have extracted most of the value. But what about the rest of companies, small and large, that actually want to extract value from the data? Where can we get the data from? And this is what led us to be building Ocean. And I'm just going to drill into what Ocean is about very quickly. In a nutshell, we saw that we want to level the playing field. We want to equalize the opportunity for people to share data, to exchange it, and so on, without loss of privacy, or at least minimizing the privacy risk. So what Ocean is, it's a public utility network to connect the suppliers of data and AI services around it and the consumers of it. And what this means in a very technical sense is that there is decentralized access control, so permissioning, all that sort of thing, in a decentralized network, as well as orchestration. So think like AI compute pipelines, grab some data, and then do some data cleaning, and then store the data, do some AI training, et cetera, et cetera. So Ocean gives you that. It gives you data marketplaces in a box. I'll talk about that. You can buy and sell private data while protecting privacy. And that sounds crazy because it sounds like a paradox. And I will show you how it's not. And it also allows you to rethink the idea of data custody. So, Andreas Antonopoulos is famous in Bitcoin world for saying, not your keys, not your Bitcoin. Well, we can actually apply this to the blockchain perspective as well. Not your keys, not your data. And so I'm going to talk about these things, but because this is for Odyssey and for the hackathon, I'm going to spend a lot of my time focusing on how things that you might be able to build open data ecosystems at the Odyssey hackathon and so on. And I should ask, how many of you in the room are developers? Okay, cool, great, about half. And how many people are wannabe developers? The rest? No. So how many of you are entrepreneurs or business people wanting to build? Okay, great. The other half, awesome. Look at that. Cool. Okay, so here's a bit about the architecture of Ocean. It was inspired in many ways. So flight tickets. So if you think about, if you go to kayak.com, you can search for flight tickets, and you will see tickets from Air Canada and tickets from EasyJet and so on. And that's because under the hood, Air Canada, EasyJet, and so on have actually put their tickets into one database overall. And so that's what it's showing here. There's a backend for Kayak and EasyJet. But if you want, you can also go to kayak.com and easyjet.com directly and buy the tickets. So there's this underlying database that sort of has the liquidity of the whole airline industry, as well as the whole hotel industry and so on. And that's called the Sabre database. And the thing that's being sold is flight tickets. So there's sort of this layered approach of the infrastructure. Another example is the world of Bittorrent. So at the very heart, there's the Bittorrent network that has all the data that people have put into Bittorrent. And then on top of it, there's many, many, many torrent trackers. And then on the top of that, you've got UXs, things like Kazaa and stuff. It's the same thing for the DNS with the torrent trackers would be replaced by GoDaddies of the world. And then the lower level stuff is administered by the registrars and so on. So this is what Ocean is about. So at the heart of it, there's at the bottom layer, there's the data that sits on premise with whoever's using it. And then what is here, Ocean smart contracts running on an Ethereum VM-based network, it's really the handshaking. On top of that, there is a metadata store that helps people to search. And then finally, there's many, many front ends that people can use. So there's data commons. We've built a template for that. There's data marketplaces that people are building, and data science tools that can integrate into Ocean, and that's happening too. So this kind of gives you a flavor for the architecture. This is another way of saying the same thing. There's data assets, and then in the middle, there's the consuming, which basically unlocks the assets, the access control. And on the top, you can do things like publish your data set, do querying to discovery, and do transfer. And on the left here, this is an example of a DApp to be discovering data. And some of the benefits, I'm going to drill in on the use case of data marketplaces. So there have been a lot of data marketplaces in the past, but they've had some challenges. They've had to have custody of the data. So in the world of blockchain, this is the equivalent of Coinbase. If you have your Bitcoins sitting in Coinbase, what happens if Coinbase gets hacked? So many of you might have had your coins in Mt. Gox, and you might have lost your coins in Mt. Gox back in the day. But compare that to decentralized exchanges, where in a decentralized exchange, there is no custody. The exchange itself does not have custody. You have custody of your coins. So it's a similar thing here with ocean data marketplaces. They are set up where the marketplace itself does not have the keys to your data. Only you have the keys to your data. Then there's the data management, where the access control, it's moving towards being tokenized. And then finally, an out-of-the-box marketplace. So if you want to build a marketplace, we already have some references. We recently had a challenge, a set of prizes, where many people built some really cool marketplaces, and many of those are open source as well. So basically, Ocean can help you to create a data marketplace for yourself, running on the lower-level Ocean stack, but leveraging the templates within the Ocean ecosystem. So an example for this is in Odyssey, there's the Conscious Cities track, where there's a very explicit place within the track. This is sort of the way the ecosystem is organized for use cases with civic support and so on. There's a place for a data marketplace, and this is one of the tracks that Ocean is deeply involved in, where the citizen data, third-party data, government data, and so on can be exchanged securely via an Ocean-style data marketplace. And sometimes it's just exchanged without selling. Other times it can be sold. It's really what you want to do. And then there's a REST API to be doing publishing, querying, consuming, and transferring of the data. So that's a lot of the role that Ocean will be having at Odyssey for this track, and actually similarly for many other tracks, whether it's Sovereign Nature track and so on. And finally, the Ocean team will be at Odyssey for tech support as well, to help people build. So what I've given so far is a high-level overview of what Ocean is about. And I'm going to drill into a few specific benefits and then give more examples. So I'm going to give an example from the world of health. Let's say you're a medical researcher trying to build a model to predict Parkinson's. You might have access to data from one hospital, if you're lucky. A friend of mine, he's actually doing cancer research, and he has data from one hospital. He has a data set of 100 people. and he's using genetic data. So he's got thousands of input variables. His models are terrible, completely terrible. You can't predict anything with that, basically. But ideally, you would have data from 10,000 hospitals, right? So 10,000 hospitals, 10,000 people per hospital, 100 million people or something. But of course, normally, if you do that, it is a privacy nightmare, right? And this data is, you want it to be private and so on. And so you really want that private data. But if you merge it all together, it's really a problem. As well as the hospitals themselves, they each want to maintain control of the data. They might be legislated to as well. Any data sitting inside, and medical data sitting on European soil needs to stay on European soil. So we've got these showstoppers, right? So what do you do about that? A way to think about this is you can have no data at all, which is kind of what's happening with my friend and a lot of medical researchers. Or if you have tons and tons of data, then you'd have a way more accurate model, right? So maybe for predicting Parkinson's, instead of 20% error, you might have 1% error, which would be great. You could save a lot of lives. And it's not just for detecting a disease, but also diagnosing in detail, as well as identifying treatments, right? So we know that more data is going to really, really help in terms of health benefits. But you've got massive problems with privacy and with exploits, right? And so how do you balance this? Right now, it's sort of you can either have nothing or you can have lots. So it's a double-edged sword. So what we have built with Ocean is the following. You can resolve this double-edged sword by bringing compute to the data. So the hospital data stays in the hospital. And your AI training algorithms come to the private data, and they train against the data there. You end up with a private model, and then that private model stays private, and the predictions are given back. And in doing this, and Ocean basically plays the role of middleman orchestrating. And so you can do this in a single setting, which is sort of like running a Docker container locally at the hospital with algorithms beside. But you can also do it in a setting across many, many hospitals. And in that case, it's something called Federated Learning. And traditional federated learning, traditional as in like the last 3 years, the middleman is Google basically, right? And then Google sees what's going on in between, and that's of course a problem. What you really need is a middleman that is decentralized, that can't see what's going on, and that's really what Ocean is designed to do. So overall, the idea here is bring compute to the data with Ocean, and this is where Ocean is doing the orchestration. It's saying, take the algorithm, take the private data, do some training, store the final model, and then do prediction when requested, okay? So that's the idea of bring compute to data. And then to this trade-off that I talked about, now you can have the accurate AI because you've essentially merged the data sets together. You can save the lives and so on, but at the same time, you are retaining privacy and control, right? So this, by the way, is out there already in Ocean Code. We've been talking about this for more than a year or so now, but it's actually finally out there quietly shipping. So we'll be having blogs on that very soon. So in the end, this is the data you'll get. Data across 10,000 hospitals, as an example. So now I'm going to talk about, with regards to these different Odyssey tracks, I'm going to talk about data marketplaces. And on the heels of that, also some more, I guess. So if you think about it, there's people that own these problems. Maybe they are trying to predict deforestation in rural Africa, and you've got the problem solvers. And basically, the problem owners. Maybe a better example. I'm from a farm in Canada, and we would have these waves of bugs coming in every year, and we didn't know when they would come, so we would try to tour the fields every 3 days, rotation. But sometimes the bugs would come in, and within a day and a half, they would devastate the whole field. So what you really want to be able to do is very, very, ideally we would be able to check daily all the fields, or even every hour. And then as soon as we detect the first bugs, then we can do spraying to stop the bugs and stuff. So we would actually have as much as 1/4 to half of our crop devastated growing up any given year because of bugs just coming in, right? So that's a problem, right? It really affects profitability. Yes, you get insurance, but insurance starts to get more effective if bugs starts to get more expensive if bugs keep eating it. So the problem solvers, people are starting to use AI to detect the bugs. AI at the ground level as well as at the higher level with satellite imagery, right? So, but the farmer in the field, he doesn't have the AI skills, right? So how do you connect the farmer in the field with the satellite imaging people that have some data, with the people that are looking to solve the problem, the AI experts? And these aren't very well connected. What we're trying to do with Ocean is to make it where you have a connective tissue around the data that connects the data owners, the storage and compute, the problem owners, the farmers, with the problem solvers. So the problem solvers can take all these other things, the data, the storage, and the problem itself, and to actually come up with an effective solution for the farmers or whatever. And in between, there can be things like marketplaces and commons, prize platforms, data science tools, and so on. And so part of our overall vision in Ocean then is that there's a whole bunch of data marketplaces, ones for data just for farmers, ones for that are a bit more broad with just satellite data, et cetera, et cetera. And on the top, you have the data haves and the data wants, basically. And the result then, as an example tool, this is commons.oceanprotocol.com. So it's a commons marketplace. The data is for free. And in there's a bunch of data that we just have as demonstrators. And basically, the benefits of these, I hinted before, your keys, your data, not your keys, not your data. So the seller can retain control of the data. There aren't data escapes. You can buy and sell private data, which kind of sounds crazy, but it's really about buying and selling access to the data, which is all that really matters. It's for AI eyes only, if you will. And that way, you don't need to trust the marketplace owner because they're not holding the data. And another thing, the marketplace then isn't liable for the data, right? After Mt. Gox went down, the founder of Mt. Gox ended up in jail because he was liable and he didn't do a good job on handling that, right? And another cool thing then too is when you have many, many data marketplaces, you start to get liquidity across these because you have Ocean as this underlying template. So I talked about data marketplaces and how you might be able to build ones for your track. We can also talk a bit about data management. So in data management, you guys probably notice, if you read the news, every day or every week, you'll hear about another breach. A big one, for example, was 2017, Equifax. They are a credit card rater in the USA. 148 million people's data was compromised. And it was their names, their social security numbers, birth dates, and addresses. They had to pay a $700 million fine for that data breach. Probably now they'd have to pay even more as GDPR has come online. And Facebook has been hacked, Yahoo, LinkedIn, all of these, right? So this is really a problem. Data breaches are the norm. Now let's think about Bitcoin and blockchains. They're kind of crazy secure because they follow a very different security model. Bitcoin has sort of this built-in bug bounty. If you manage to find a flaw in Bitcoin that compromises the security of the Bitcoins, if you're an amazing hacker and you find that flaw, you might make $1 billion. But that hasn't happened at all for years and years and years at any scale at all, really, because Bitcoin has been hardened. So it has these built-in bug bounties, if you will. And the fundamentally different security means there's no central point of control, and you have like thousands of independent nodes that store the most important information, right? Which is basically the list of transactions of who owns what, right? So if you think about it, though, you can actually take the architecture that was in Bitcoin and you can apply this to blockchains for other things, including for data management, right? And this is really what Ocean is about here. So if you're thinking about data management within the enterprise or within the government, then that means custody and it means transfer of data. So data custody can start to become blockchain token custody. So we've seen this emergence of blockchain token custody, a whole infrastructure around that. Everything from very simple custody, wallets on your phone, add-ons in your browser, to much fancier custody, multi-sig with Gnosis Vault, or even enterprise-grade ones like we see here. This is from Riddle & Code. It's their enterprise-grade multi-sig wallets. And so now you can basically leverage all this wonderful infrastructure of sort of bank-grade security that has been used for blockchain, traditionally for tokens, now we can use for data itself. And then transferring data basically comes down to similar, in the same way that you would transfer Bitcoin or Ether, you can use this to transfer data access. And then you also inherit the properties of security over time. I'm not saying this is a panacea, though, because I know enough about security. I can't say, okay, we have amazing security. This is a thing that will take years over time, but it's a much better starting point, I think, compared to what we have now. And then from a smart city data management perspective, if you, a very favorite example I have here is Estonia, where Tallinn, the main city, and most of the population of Estonia lives there. They have a data management system that they've had since 2001 called X-Road, and it's served Estonia extremely well. They've had more than 30 government applications living on top. And kind of how Ocean is designed, it sort of takes a lot of those ideas for data management, but then leverages blockchain and all the benefits that blockchain gives you. So there's the data management at the core, which is really about custody and transfer of access controls. And then on top of that, you can layer in identity and payments. We all just saw the talk from Christopher Allen. There's tons and tons of identity providers now built on the DID specs. Payments, this can be with stable coins or euros or whatever. And then finally, all these applications on top for cities that cities can have. Just like in Estonia, Estonia has everything from parking to taxes to legislation. And of course, many third-party applications too. So we are quite hopeful and excited about Ocean being used for data management in cities. And we're iterating with maybe some of you in the room here on that. Another example is for ecosystems such as energy. So we're iterating with Energy Web Foundation folks on their authenticated data work. And so this is one of their very first applications is authenticated data. And Ocean can be helping to connect this with the data marketplaces and so on. So I'll just zoom forward. So now I'm going to zoom into basically how to build an Ocean and try to give a lot of time for questions and whatnot. Let's see how I'm doing. Okay. So Ocean Tech, it's a public EVM-based network, and it has a bridge to the Ethereum mainnet itself. And by doing this, it has scale, so it's low latency, low cost to run, to make calls to and whatnot. And then on top of that, we have SDKs in Python, in JavaScript, and community-based Java SDK as well. Finally, there's a REST API. So that's the basic usage. Of course, all the code is open. We are in blockchain land after all, so github.com/oceanprotocol. The docs are all at docs.oceanprotocol.com. So we have tutorials and setup guides and this sort of thing, ways to get going. And one of the ones probably for relevance here is we have a quick start to build a React-based application. So, so in this particular quick start, you just get this My Little Ocean thing on the right. So it's pretty empty, but it's a template just to get going with. I'm going to describe just a few things that people have built on Ocean in the last couple months. We actually had something called a data economy challenge. And so as part of this overall competition, there were some really, really great things that popped out. So I'll show you a few. This is Decentramind, and it's I'll just describe self-sustainable research communities through trustless and privacy-preserving infrastructure. So it's a marketplace, but it also has a built-in wallet, support for several wallets. So MetaMask, Portus, and more. And Portus is interesting because it has fiat on-ramps. It has some special data wallet tools, such as a faucet, some exchange with Uniswap, and so on. And it also has a little bit of its own data challenges too. So this was Decentramind, one of the winners from the competition. Another one is Ocean Rewards. So here, people can share their mobile app data and get rewarded in Ocean tokens, while app marketers can purchase that data with Ocean. So a two-sided marketplace around mobile app data. And there's a whole bunch of other things that could get built though. So maybe these are inspiration for data marketplaces you might want to do. For example, bundling data sets into data set portfolios, maybe using set protocol, or pricing data with bonding curves. In fact, one of the competitors used this, I'll show later. Or imagine having a marketplace for data labeling and implement it with a DAO. Or a market with built-in data exploration and visualization. A marketplace for synthetic data, which is another privacy-preserving approach that's complementary to what Ocean already has. Or pricing data using channel auctions, which is sort of a combination of a traditional Dutch auction and English auction, and more and more. So, so if you want to do more marketplace stuff, here's some links. I can share these slides afterwards too. And most of this is straight off of docs.oceanprotocol.com anyway. So, also integrations. You know, what if you want to integrate into some other cool things? So here's something from the team at Molecule called Molecule Data Swap. And it's for crowdfunding production of Ocean assets, data sets, and so on that can then be sold. And these guys actually have pricing with a bonding curve, which is very cool. Another one is Slack integration. So basically, they built a whole, this team, the Manatee team, they built a whole data marketplace in Slack. Can you imagine that? So you can publish an asset on the left, you can do discovery searching, and then you can explore what's already there. So a very, very cool mashup that, in this case, lives where sometimes the users live. Another example is for streaming data. So the initial template Ocean marketplace was only supporting uploading and downloading of files. The backend architecture of Ocean supports streaming, but none of the front ends did. And so this team, the Osmosis team, actually built a streaming driver so that you can be buying and selling streaming data. And of course, streaming data is rising in prominence, so this is quite important. Here's some other examples of integrations that you might want to look at as part of the hackathon. Integrating into Filecoin, it's coming out of beta soon. Ethereum Swarm, or Storage, or SIA, or Chainlink data feeds. And by the way, we have a prototype of that already on one of our blogs. Or there's bots coming from Fetch.ai and Seed and SingularityNet, each with their own really cool flavor. And these things are starting to come live now. Enigma has their SGX compute. There's other TE environments out there as well. And finally, what about all the DeFi stuff, right? So can you have data loans leveraging Compound somehow? Or leveraging Uniswap, where you're trading back and forth, including Ocean tokens, but also Ocean-derived tokens for data. Synthetic assets, and so on. Other examples for you guys for building. What about integrations into data science tools? So for example, what if you I talked about building models next to the data itself. A good example of that, if you only want to have just not federated learning, but a single data set, scikit-learn is a good choice because it's meant for small models, small compute, where you have things like linear classifiers and so on. Another one is, what about provenance of the model training itself, right? So you want to prove that you train the model, so you could be posting intermediate model training results to the chain itself. Anaconda Cloud, so Anaconda is the leading Python-based data science platform, and they all have a cloud version of what they do, so you can integrate into that. OpenML has 20,000 data sets, so you could be integrating with that. What about selling models, right? You could have a marketplace for selling models. So what about some integration with Tensorflow, where as soon as it gets built with Tensorflow, it gets published to an Ocean data marketplace, but not just any data marketplace, a Tensorflow model data marketplace, right? So a lot of different ideas of things you can do here, and then these, of course, can riff with the different tracks that are as part of Odyssey. And then, there's a lot of other cool things that could be built, have been built. This is a cross-browser extension, so it kind of looks like MetaMask, but it's an Ocean marketplace, basically. Another one is just a crypto fiat on-ramp. Another one is an app inside Android. And there's lots of other wildcards that could get built as well. Everything from data DAOs, I think that's a really big one. A block explorer that has integrated data set visualization, and more. So to wrap up, Ocean has a role at Odyssey, many of the tracks. The example, like I showed before, with the smart cities, where it plays the role of data market. And to conclude, Ocean is, in a nutshell, a way to safely and securely exchange data without loss of privacy. And it has lots of other cool features, but if you want to build, docs to Ocean Protocol is the place to go. So I will stop there and see if there are questions. Thank you.
Kaboom! So I don't know if I'm getting smarter or you're making it easier to understand, but I actually got almost all of that compared to the first time I said it. I'm going, I have no idea, but it sounds fantastic. But I did have one question, and remember, I'm not a techie, so if you can answer it simple. What is synthetic data?
That's a great question. So overall, the idea is if I have a data set of, say, 1,000 people's worth of DNA, or 1 million people's worth of DNA, right? Which is scary. I don't want to, and you're a machine learning researcher, I don't want you to see that and build on it and have access, right? So the main Ocean trick is that you can bring compute to my premises, build
so
a model and so on, right?
I bring you a question and you give me an answer instead of you giving me the data.
Exactly, so that's one way. So synthetic data is another solution, and the idea is I build a PDF, a statistical distribution, that describes all of the DNA data of all those million data points. And then from that, I actually draw another million samples from it, or even a billion samples from that PDF. And then I give you those new samples. So it's sort of, the hope is that it is sufficiently anonymized, right? Because
so it's statistically relevant, but so much information that I can't rebuild it or track it back, or so you give me all of the answers, but without the data.
Yeah.
Clever.
Yeah.
Okay,
so it's coming online. A challenge with that, of course, is that it's only as good as the PDF. And if you spend all the effort of model building to build a PDF, why not just build a model directly, right? So synthetic data, while it's kind of cool, you actually add error on top of, you have the error from the synthetic data generation plus the error of modeling. So you have sort of two sources of error, rather than if you build the model directly, then it's just lower error.
So work in progress.
Yes.
Fabulous. Questions from the audience?
Well, yeah, so basically synthetic data I see as a work in progress, but I see that compute to the data is a more pragmatic solution.
Yeah. I see one gentleman very enthusiastically raising his arm in the middle, but there's no way I'm going to get a microphone to you. So if you say it nice and loud, and Trent's going to repeat it for the camera.
So I kind of hate to ask this because this was a really great presentation, but do you think tokenization is really a feasible way to set up these marketplaces? You know, one specific token aside, because tokenomics are just so messy and subject to so many different market forces.
So I think maybe if I can read correctly, so is your question, does the marketplace need to rely on using Ocean as the token to buy and sell data as the unit of exchange? So it doesn't. In fact, right now you can right now it's designed where it has that, but we're shifting the design such that it doesn't need that because there's very poor value capture there anyway. You don't really need it as the unit of exchange. And so you might have seen we wrote 3 blog posts on data tokens in the fall. And those data tokens, if you think about it, those are not tied to the Ocean token at all. And you want these tokens to live on things like OpenSea, Mintbase, and other NFT marketplaces. And OpenSea isn't going to switch from using ETH to Ocean, for example, right? So and that's completely fine with us because we see that there's other places that have value capture for the Ocean token and that you don't need to have it as a unit of exchange, right? Yeah. So
all right, we're running out of time.
Ask the hard questions, please do.
You were second with your hand up, and I can get the microphone to you easiest. This is a very democratic process, of course. And I learned a long time ago, never give an audience member the microphone, so no. No. No.
All right. Thank you. And it was a good example with the hospitals, most of all because they have a mutual interest, saving lives. But how do you see this work with commercial companies where it's most of all a winner takes it all and a company with the most data has the best insights? So I'm kind of figuring out how to build an enterprise algorithm where, all companies build a data set together and together get the best insights. But if you compete, what do you think?
It's definitely a question. Maybe a good example is the world of automotive for self-driving cars. So Rand did a study where they saw that 500 billion miles driven was needed. That much data was needed in order to have self-driving cars that were safe enough, and therefore self-driving algorithms that were accurate enough. And so one of the sparks that started the Ocean project in earnest was Toyota Research came to us in early 2017 and said, hey, we're working on self-driving cars. We ran the numbers. We realized it's going to take us more than a decade to get enough data to have our cars accurate. So we need a way to merge our data with the data of many other automakers. And so we actually built a prototype for them based on BigchainDB at the time. And then from that's actually what that project evolved into what is now Mobi, this mobility alliance for self-driving cars, but many other things. And we see that the automakers that are part of Mobi are incentivized to work together because they are part of this new competitive landscape, and they don't want to get crushed by the people that are trying to do it on their own. And there's at least 2 companies trying to do it on their own, Waymo from Google, as well as Tesla. And they're gathering data like crazy. So Tesla's idea is that we're going to just run away and do it ourselves. Same thing with Waymo. But the automakers themselves, the rest of them are working together to pool their data. Who will succeed? We will see. And I think in some cases, pooling your data makes sense. Other cases, maybe there will be a runaway. The airline industry with the Sabre database, they pool their data and they all benefit from the sales, right?
And I think that's a really good metaphor for what the Odyssey level challenges are really about, enabling that mass collaboration where a winner takes all is really not going to solve the problem anyway. Yes, you promised me you're going to give this microphone back and you're not going to do anything stupid with it. He's like shaking his head, no way.
Okay, I've read somewhere that Facebook is earning like $25 a year on my data. So is it really worth will a person be incentivized to sell his private data, given that as an individual your data is not worth that much? It's the masses that is worth a lot.
It's the masses, but this is basically Facebook taking advantage of the fact that we haven't organized ourselves. So, in rural Canada, I grew up on a farm in Saskatchewan. In the early 1900s, the farmers, they were growing this grain, but they had nowhere to sell it. So they needed to have some means of collective bargaining, and they formed the Saskatchewan Wheat Pool. And more than tens of thousands of farmers got together. They formed this thing, and collectively they would sell their grain to Japan and elsewhere. So and within the Saskatchewan Wheat Pool, they had it was a large enough organization that they had full-time employees going through the task of marketing the grain, collecting it, distributing it, and so on. I see the same thing with data, where individually, we're not going to go and try to, find that one person way far away. But what if we can have collective bargaining on data via data trusts, data unions, these sorts of things? And so Ocean can be a piece of helping this with really management of the data itself. But we see, on top, how do you manifest this? It's with things like DAOs. And I think Matan from DAOstack is speaking right after me in this room. So maybe he'll be talking a bit about data DAOs as well. I'm not sure. But that's a very nice use case for DAOs. Yeah, collective bargaining is going to be important. And maybe you have, and in terms of the value of the data itself, Facebook, yes, 25, but 23andMe, I signed up for them 10 years ago. They promised that they would never, ever sell my data. I saw in the news recently that they have sold everyone's data for $60 a person, right? And I tried to delete my data before they sold my data. I couldn't do it in time because I was trying to download. So they made $60 with just one contract, right? They're probably going to make $1,000 or more from every single person for the data. So your data is valuable.
Right. I mean, could be easy enough to imagine selling your data to your local hospital, but sell it to every hospital, even if it's a Barker hospital. That makes a big difference, but you can't do that. I can't do that. I mean, maybe you can. I can't. I've got one man here tugging at my sleeve saying, give me the last word, give me the last word. So he's the boss.
No. I just have a question. So, thank you, Nick.
No worries.
So, just a question, Trent, because Ocean Protocol, the name Ocean, relates a little bit to one of our challenges, protecting marine biodiversity. So, I mean, this is a real practical stuff, and we've come a long way to the level that people can now start implementing this. And when you're, let's say, a biologist, and you're looking at a patch of sea of, let's say, 1 million square kilometers. You can imagine that there are loads of data sources that could be of value. Could you paint something like a picture where if Ocean Protocol would work for the ocean, where could we be in, let's say, 5 to 6 years if we start now?
No pressure.
Yeah, well, in a nutshell, I think
asking your imagination to work.
So I think, in a nutshell, I think we could get a lot farther. So I'll just take the U.S. alone. So the U.S. has this agency called the NOAA, and with that, they spend tens of billions of dollars a year. I think more than a third of their budget on weather prediction, and so we're talking, billions and billions of dollars for weather prediction. every day, thousands of weather balloons are sent up in the air to detect humidity and many more things. And they also have thousands of buoys all throughout the ocean to see what's going on in the ocean currents. So there's tons and tons and tons of data gathering effort that has been going on for decades. And it started to get a lot better in the last 15, 20 years because, supercomputing, all that, right? It's one of the biggest uses of computing. Now, this data has actually been made available because it's part of the US government funded. It's actually available for people to download and use. But traditionally, it's, and there are weather companies that sit on top that build apps that they claim they make better predictions. And sometimes they do, sometimes they don't, but they always claim they do. But it's really hard for the average person to take the time and effort to use that data in other ways because there aren't that many other established marketplaces for using this data in novel ways. But this is where Ocean can help because the data, you can actually set up a data marketplace with much lower friction that uses some of this data for new applications, new niches, and this is where Odyssey could be useful. So within the Odyssey Ocean track, it's taking this data that's already out there through the NOAA and others, and as well as other data that has been gathered towards the goals of the track with helping to clean up the oceans and the marine life, right? So that's what I see is Ocean can basically be lower friction in setting up marketplaces to connect the dots at the higher level, given that the data is already there, but kind of half hidden.
I find that fascinating. I hadn't thought about that, actually making a leapfrog from all the volumes, the literal oceans of data that we already have, but can't easily access, to using things like Ocean Protocol to make that accessible. So not even having to dream of new things and new solutions, but what's staring us in the face, but got disappeared. And your timer went off just as you were speaking, which means we must be fantastically on time. I know some of you have still got questions. Trent, are you hanging around for the afternoon?
Yes.